In this video, we will be going over the properties of solids. So there are four main types, and we're going to go into each of them further in this video. But for an overview, the four main types are covalent network, ionic, molecular, and metal. So first let's start with covalent network. Covalent network. So the important thing to remember here is that these structures are really, really strong, and they're characterized by really high melting points. High melting point. Their structures are 3D and not conductive, with the exception of graphite. So some examples of covalent networks are graphite, diamond, and silicon dioxide. There's also quartz. Okay, so now moving on to number 2, ionic. So what makes a compound an ionic compound is if it is comprised of a metal plus a nonmetal. So an example be sodium chloride. And what's interesting about the ionic solid structure is that it's made up of positive and negatively charged ions together in a repeating and alternating lattice structure. So what that means is it'll look something like this. So the positively charged ions are smaller, of course, because the anions are larger due to electron repulsion. And you see how the same ion, the same charged ion, is never touching itself because of the alternating structure. So if you're ever asked to draw an ionic structure or identify one, it looks similar to that. Okay, and then another thing here is that ionic solids are conductive when aqueous. And aqueous just means when dissolved in water. And also they're conductive when they're molten, but typically we're asked when they are aqueous. Okay. Number 3, molecular. So these are discrete molecules comprised of 2 nonmetals. So nonmetal plus nonmetal. These have really weak intermolecular forces. Intermolecular forces. So they have really low boiling points, especially compared to covalent network solids. And an example of a molecular compound, molecular solid, would be chlorine. Okay. And then last but not least, we have metals. So examples of metals would be iron, nickel, aluminum. Okay, and so the big thing with metals that we see is that they talk about a delocalized sea of electrons. Sea of electrons. So basically electrons are shared in that delocalized sea of electrons instead of electrons being stolen or given. Metals are also conductive, malleable, and ductile. And those are the properties of solids.